Okay, so today we're going to be looking at chapter 5.1, and we're going to be looking at relations on page 256 to 261 in your textbook, and this is outcome R1, okay? So in this chapter, in chapter 5, so if you look at the title page, there are a bunch of different outcomes that we're going to be looking at, and they're all related to relations, which sounds kind of funny. Okay, so basically a relation is a relationship between two things, right? So here in this table here, we've got animals in this column, and we've got class in this column. And these animals belong to that class. So ants belong to Insecta, eagles belong to Aves, snakes belong to Reptilia, turtles also belong to Reptilia, and whales belong to Mammalia. So now here the first thing says describe the relation in words. Now what we have here is we have the relation shows the association which is belongs to class, belongs to the class from a set of animals to a set of classes. All right, so that's the relationship. So it's the association of belongs to the class from a set of animals to a set of classes. So here are the animals and here are the classes. And it's showing you which animal belongs in which class. Here it asks for you to represent it as a set of ordered pairs. Now, ordered pairs is when you have a bracket, comma, x value, comma, y, sorry, I said comma a couple of times, didn't I? So a bracket, x value, comma, y, and close bracket, okay? So these are like just the same way that we list coordinate points, all right? So, but over here we don't actually have coordinate point values as in numbers for my x, y axis. What do I have? Instead I have animal and class. So what I'm going to do is I'm going to write the ordered pairs so that they are in, so animal is going to be first, and then second is going to be class. All right, so that's how I'm going to list each ordered pair. Now, do you remember how we bracket a bunch of points that we're listing, or a bunch of data points that we're listing? What kind of brackets we use around all of them? So we want to put all of our points in that curly bracket. So I'm going to open my curly bracket, and then first I'm going to have ant, and then I'm going to have Insecta. Okay, because these two appear on the same line here. So over here on the same line. All right, now in between each coordinate, I'm going to have another comma and then bracket, and next I'm going to have eagle. So eagle and then comma. What comes next? Yeah. And then snake and reptilia. I only have one L, sorry. And then turtle and reptilia again. And I'm going to continue down here, whale and mammalia. And then I'm going to close my bracket over here. All right, so that shows you the set right there. You've got your two curly brackets in the ends, and then all the, you could think of them as points inside. All right. Now, an arrow diagram. An arrow diagram is something where you have two sets and you connect them together with arrows. So if they are a coordinate point like this, a point like this, then we want to connect that together as arrows. So first what I'm going to do is I'm going to have an oval here, and I'm going to write in all of the words. So ant, eagle, snake, turtle, and whale. Okay, and then I'm going to have another oval, and I'm going to write each of these words in there. Okay, but before I do, I'm going to make a point here. Each item is only written once. All right? So you notice something about the classes here? Reptilia shows up twice. So how many times do I write it in here? Once. All right. Now, let's write it in so that we've got insecta, aves, reptilia, and then mammalia. Okay. Where does eagle go to? So now I want to draw an arrow to aves. Now snake goes to reptilia. Okay. Why did I forget about ant? Ant goes to insecta. And then, excuse me, how about turtle? That also goes to reptilia. So you've got two of them going to the same one. And then whale goes to okay. So if an item shows up more than once, you only write it down once, but the arrows, it might have two things going to it, so you just show that with the arrows going to it. All right? So that's an arrow diagram. All right, now, the next question, number 2, looks at different towns in British Columbia and how they can be associated with average time in hours it takes to drive to Vancouver. So this is how long people are spending on the road to go from one place to another. So if you're traveling to Vancouver, if you're in Horseshoe Bay, it takes you how long approximately? Okay, so, and that's not quite an hour, it's like 3/4 of an hour, 45 minutes. And this one, how long if you're in Lillooet? So 4.5 hours. In Pemberton, you look up here, you look across, so 2 hours and 45 minutes or 2.75 hours. And Squamish, an hour and a half. And then Whistler, how long does it take? So 2.5 hours. Okay, so now in this first part it says, represent this relation as a table. So how do we make a table of values? What do we need first? A heading. The first thing we're going to head is town, and then time. Time in hours, okay? We could be a little more specific and say travel time. Okay, never hurts to be a little more specific. So the first town, we're going to just list all the towns now. So we've got Horseshoe Bay. Then I've got Lillooet. Then we've got Pemberton, Squamish, and Whistler, All right. So I'm just going to create my little table of values here. And now I'm going to write in the times for each one. So what did we say for Horseshoe Bay? So let's all use the same units, okay, the whole time through. So let's use hours as our standard unit. So instead of 45 minutes, I'm going to write 0.75 hours. And then for Lillooet, it was 4.5 hours. Then Pemberton, we said 2 hours and 45 minutes, which is the same as 2.75 hours. And Squamish was 1.5 hours, and Whistler was 2.5. Sound good? Yeah? Okay. Okay, so now we're going to do an arrow diagram. Now, an arrow diagram, let's actually give this arrow diagram a title. I forgot to give the one previous a title. So I would have average time in hours to drive to Vancouver. All right, so that would be my title for my arrow diagram. And it's going to go in this direction, from left to right. So what are the things I'm going to list in my two ovals? I'm going to try to make this one a little bigger. So the towns are going to go here. So Horseshoe Bay. Okay, Lillooet. Pemberton. Squamish. Whistler. All right, now, what's going to go in this oval here? The times in hours. Now let's have a look at the numbers that we have. Do we have any that double up at all? No? Okay. So why don't we list these numbers in numerical order? Okay, so listing these numbers in order. We're gonna end up with a list looking like that. And then Horseshoe Bay, Lillooet took us 4.5 hours. Pemberton was 2.75. Squamish was 1.5. And Whistler is 2.5. So these are just a couple of different ways that certain graphs could be represented, and it's just important that you know how they are read or how you can draw them. All right. So the next one looks at so this is the arrow diagram that it's referring to when it says describe the relation in words. So here, over here is the question. It says in the diagram below, and then it says describe the relation in words, but you really don't see anything until you move down. So it's this diagram below that we're looking at. So what is the relation that is shown here? and this says English words, and then has this number of letters, and then natural numbers. So this relation shows the association has, so you give the title, this number of letters. So you write, this relation shows the association, and then this is the title that we see on our arrow diagram. Has this number of letters from a set and then it's the first part of the arrow diagram, like the first oval or the first square in this case. To a set of, and then the second oval or square of natural numbers. All right. So this is the first oval and this is the second oval, and you're just showing that there's an association between the two. Okay, now comes the fun part. Let's actually do a couple of examples of these. Okay, so if I have the number or the word, so I'm going to write an English word. So its coordinates are going to look like this. English word, and then number of letters, right? So if I write the word animal, what's the value associated with that? 2, 3, 4, 5, 6. So 6. All right. You give me one. Hopefully something I could spell. Math. Math. Wow, I love that. Perfect. Beautiful word. Four. Why? Because the word math has 4 letters. Let's do another one. Protein. Oh my goodness. Okay, you have to spell this one. P-R-O-T-E-I-N. I'm always afraid I'm going to mix up the E and the I. That's my thing with the word protein. Okay, 1, 2, 3, 4, 5, 6, 7. Okay. Do you get the idea? You want to do the other one? Friday. All right. Friday has 6. Okay. Perfect. Just for giggles, let's make an arrow diagram now out of this. Yeah? Okay. Let's do an arrow diagram. Arrow diagram. Okay, so what is going to be the heading of my arrow diagram? Okay. Has this, or I could say word, has this number of letters. All right, and it's going to go in that direction. And then what do? Words on this side and numbers on the other. So animal, math, protein, Friday. Okay, and then what am I going to write here? the numbers. So I'm going to write 4 and then 6 and then 7. So I only want to write each number once. So where does animal connect to? 6. So I draw an arrow to 6. And then math goes to 4. And then protein goes to 7. And then Friday goes to 6. All right. Perfect. Awesome. Make sense? You guys get it? Yeah. Okay, sweet. There is the homework, and yeah, we'll have some fun.